Imagine peering into our cosmic neighborhood and stumbling upon a potential giant planet orbiting right within the habitable zone of Alpha Centauri A, the closest star system to us that resembles our own sun. But here's where it gets controversial. Recent observations with the James Webb Space Telescope, JWST, might have just unveiled this elusive world. JWST targeted Alpha Centauri A, using its state-of-the-art MIRI coronagraph at a wavelength of 15.5 micrometers, capturing 3 separate images spread out from August 2024 to... The sensitivity achieved is truly groundbreaking. They could detect point sources with a contrast ratio as small as 1 in 100,000 to 1 in 10,000, and angular distances greater than about 1 arcsecond from the star. More astonishing is their ability to probe for exozodiacal dust, that is, dust clouds similar to our solar system's zodiacal dust, around Alpha Centauri A. The limits are around 5 to 8 times the brightness of our solar system's dust, which is by far the deepest sensitivity ever reached for a star system other than our own. During their analysis, advanced post-processing algorithms like PCA-CALIP revealed a faint point source named S1 in the August 2024 data. Detected at a signal-to-noise ratio between 4 and 6, or between 3 and 4 standard deviations. This source lies about 1.5 arcseconds away from Alpha Centauri A, corresponding roughly to a distance of about 2 astronomical units. Its observed brightness, or flux, was approximately 3.5 millijanskys, making it a subtle yet intriguing candidate. Extensive testing suggests S1 isn't just a visual artifact or a result of the instrument's PSF, point spread function subtraction. It also doesn't seem to be a background star or a foreground object passing in front. Interestingly, S1 was not detected in 2 subsequent observations, spaced a few months apart, indicating that if it's a real object, such as a planet, it might have moved elsewhere in its orbit, landing in a region where our sensitivity isn't sufficient at that time. To further understand this candidate, scientists perform simulations by injecting artificial signals into the data, which helps determine the detection limits and safe orbital zones. They also created detailed 2-dimensional sensitivity maps for each observation epoch, providing a roadmap for future follow-up efforts. The goal is to confirm whether S1 truly is a planet orbiting our nearest solar-like neighbor. In one of the key techniques employed, researchers used joint PCA-CLIP to subtract data segments from different parts of the August 2024 observations. Remarkably, S1 was consistently detected across all these subsets, whether analyzing the first half, second half, even or odd frames, or individual frames, strengthening its candidacy as a real astrophysical object. While more observations are needed for certainty, this work pushes the boundaries of what we can detect and understand about potential worlds in our cosmic backyard. Could S1 turn out to be a planet, possibly even within the habitable zone? Or is it likely a false lead? The next steps will be critical, but one thing is clear. We're closer than ever to spotting nearby exoplanets that could have habitability prospects. And this is the part most people miss. The process of discovery involves not just capturing faint signals, but also rigorously testing, confirming, and sometimes questioning what we think we found. So, what do you think? Are we on the verge of finding our next Earth-like world? Or is this just another intriguing cosmic mirage? Share your thoughts below.